Okay, how's it going? It's so nice to see everybody. Yeah, whatever. It's totally fine. I'm sorry I couldn't be there today, but what I need you to do right now is take out your notes, take out pens, pencils, whatever you got to do. Take out your data booklet as well. That's going to be really helpful. Um, Today's goal is for us to talk about half reactions. What we want to do is we want to be able to split up a redox reaction into two different half reactions. And so we're going to split up a redox into a reduction and an oxidation half reaction. We want to show the processes of gaining and losing electrons. Now, just as a reminder, how do you know when something is being oxidized or being reduced? Well, we've got a little acronym for us to be able to remember. Leo the lion says grr. Rawr. Okay, so Leo the lion says grr. What that means is losing electrons is the process of oxidation, and gaining electrons is the process of reduction. So we're going to write down an oxidation reaction. It's not going to be a totally complete balanced reaction, but I just want to show you a really simplified redox reaction. If you take silver ions, like you would find in silver nitrate or something like that, and if you add to that silver ion solution copper metal, what will happen is there will be an exchange of electrons. One thing passes electrons to the other thing, and you'll get a change in oxidation state for these things. So silver ions, they turn into silver metal, and the copper solid, it turns into copper 2+ ions. Now this is absolutely a redox reaction, and we should kind of remember this from last week, because anytime you have a change in oxidation state or a change in oxidation number, that's when you have a redox reaction. So take a look at the silver at the beginning. It's got an oxidation state of +1. The copper is 0 because it's an element. The silver at the end is 0, and then the copper 2+ is +2. Okay, no problem. So we take a look at this. The silver ions are turning into silver metal. So it's going from +1 to 0. That's absolutely a change in oxidation number. Already we know, yes, that this is a redox reaction. The copper is going from 0 to +2. And so let's just kind of label what's going on right now. One of these things is being oxidized and one of these things is being reduced. The silver, is it being oxidized or is it being reduced? Take a few seconds to figure out, is it gaining or losing electrons? And because it's gaining or losing electrons, is it being oxidized or being reduced? You have 5 seconds. Go. Okay. So because it's going from +1 to 0, it's becoming more negative. And if we're becoming more negative, we must have gained electrons because electrons have a negative charge. So the silver is gaining electrons. It must be being reduced. So this is being reduced. And then the copper is going from 0 to +2. I know it's going plus, but it must be being oxidized because it's losing electrons, which are negative. Losing negatives is becoming more positive, so that's oxidized. That's the process of oxidation. Good. What we want to do is we want to split this reaction, even though it's not a complete balanced reaction yet, we want to split this reaction up into half reactions to really show the process of gaining or losing electrons. Now, half reactions must include electrons at some point in time. So half reactions they show the gaining or losing of electrons. They must include electrons inside the half reaction. You have to put electrons somewhere in the half reaction. So they must include electrons. So what we're going to do is we're going to split this reaction up into half reactions. So let's identify what's going on. Well, the silver ions are being turned into silver metal. Okay, no problem. So let's do that. Silver ions, are being turned into silver metal. Perfect. Now, every chemical reaction, and I know we haven't had time really to talk about this yet, but every chemical reaction needs to follow two laws. One is the law of conservation of mass, and number two is the law of conservation of charge. So every chemical reaction has to follow those two laws. If you've got 5 carbon atoms on one side, you have to have 5 on the other side. That's the law of conservation of mass. But the law of conservation of charge says that if your total charge on one side is -10, the other side also has to be -10, or else you have a problem. Your charges don't balance, and that's a problem. Okay, so on this side, on the reactant side, we've got silver ions turning into silver metal. Well, 1 silver, 1 silver, 1 Ag, 1 Ag. That's good. That follows the law of conservation of mass. That's awesome. But if you look, the one side has a charge of +1, and the other side has a charge of 0. And so it doesn't follow the law of conservation of mass. What we're going to do is we're going to add electrons in these really simple half reactions. We're going to add electrons to balance the charge. Now, you're only allowed to do this once the law of conservation of mass has been dealt with. You're only allowed to balance charges at the very end. So we're going to add electrons. If I add electrons, for example, to the product side, is that making the situation better or worse? So we've got a total charge of +1 on the left-hand side. Now we've got a total charge of -1. Have I made things better or worse? I think I made things worse. +1 and -1 are not the same thing. Those charges are not equal. And so I shouldn't have added electrons on the product side. What you have to do when you're doing half reactions is you always want to add electrons to the more positive side. Electrons are negative, and they'll bring down the charge of the positive side, so you always add them to the more positive side. So if I add an electron plus electron, now my total charge on the left-hand side, if you add up all the charges, is -1 and +1, so 0. So 0 and 0, we are absolutely balanced. So this is a good half reaction. And you'll notice that this half reaction, remember we said that silver was being reduced. This is a reduction half reaction. You know it's a half reaction because it's got electrons in it. It's a reduction half reaction. I don't know if you can tell because electrons are being gained by the silver plus. At the very beginning of the reaction, silver plus ions combine with electrons and then turn into something. So electrons are combining with the silver plus. Let's do the copper. I'm going to write that in red. So the copper starts out as copper solid, so metallic atoms with no charge. Copper solid turns into copper 2+. And take a look at this. My total charge, we have to do conservation of mass first. So 1 copper, 1 copper. I know it's got a charge of 2+, but that doesn't matter right now. You have a single copper and a single copper. Okay, no problem. The law of conservation of mass is perfect here. But we have to balance the charges now. So a total charge of 0 on the left-hand side, and then a total charge of +2 on the right-hand side. That's a problem. Our charges are not balanced. So we have to add electrons. Now that we can't do anything with mass, we have to add electrons in order to balance that. If I add electrons on the left-hand side, I'm making it worse. you always have to add it to the more positive side. So I'm going to add the difference between the total charges, right? Plus 2 and 0, that's a difference of 2. So 2 electrons. Now the plus 2 and the 2 negative, they balance out to 0. So 0 and 0. The charges don't always have to add up to be 0. They just have to be the same as each other. So this is a good half reaction, and I don't know if you remember, but copper was being oxidized. And so the copper being oxidized, this is showing how copper is turning into something else, and then it's releasing 2 electrons. So it's giving away or losing. So this is an oxidation half reaction. Perfect. So these half reactions, they show they tell the tale of what's going on in this reaction. The silver is gaining electrons, and it's gaining the electrons that were given away by the copper. So copper gives away electrons, and silver gains those electrons. You'll probably notice the copper is giving away 2 electrons, whereas the silver is only gaining 1. And we'll deal with that tomorrow, or we'll deal with that at a later date when we go to actually balance redox reactions. So this is a great example of a redox reaction. We're going to take a look at a couple more, and we're going to use this idea of balancing the conservation of mass and conservation of charge to be able to get the half reactions for these things. So we'll try our next reaction. Our next reaction is going to be, check my notes. If you add a solution of iron 3+ ions to zinc metal, so iron 3+ ions to zinc metal, what will happen is the iron 3+ ions will turn into iron 2+ ions. And the zinc metal will turn into zinc ions. Now, zinc ions, if you look at your periodic table, there's only one possible charge for them, and that's 2+. So again, this is not a balanced reaction. I just threw the things up there, and this reaction is telling you that iron 3+ will react with zinc metal, and when they do, they produce iron 2+ and zinc 2+ ions as well. Now let's take a look at this, and let's just make sure it's an oxidation or redox reaction. So the Fe3+ has an oxidation number of +3. Zinc, because it's an element, is 0. Iron 2+ is +2, and so is zinc 2+. So the iron is going from +3 to +2. This is definitely a redox reaction because this oxidation state is changing. Take a look and tell me whether or not it's being oxidized or reduced. Actually say it out loud this time. Yeah, totally. It's absolutely being reduced. It's going from +3 to +2. It's becoming more negative, so it's gaining electrons, and so it's being reduced. Great. So this thing is being reduced. Well, if something is being reduced, something else has to be oxidized. You have to have both at the exact same time. Let's double check. The zinc is going from 0 to +2. That means it's losing electrons. It's becoming less negative, so it's losing negatives, becoming more positive. So that is absolutely losing electrons is oxidation. It's becoming oxidized. Perfect. So let's do our 2 half reactions. Let's split up into 2 half reactions. The Fe3+ is turning into Fe2+. And then I'll just write the other half reaction at the same time. Fe3+ turns into Fe2+. Zinc turns into zinc ions. So zinc metal turns into zinc ions. These half reactions are relatively simple, relatively straightforward. Remember, we're going to balance this reaction or write a complete half reaction for the iron, and we have to follow the law of conservation of mass first, and then the law of conservation of charge. So balance all your atoms or elements, and then we deal with the charge at the end. Well, this is pretty easy. I see one iron. It's got a 3+ charge, but there's only one of them. And then one iron over here with a 2+. So one iron, one iron. The law of conservation of mass is being followed here. We're going from a total charge of 3+, or +3, to a total charge of +2. I have to add electrons. Because I'm done with the conservation of mass, I have to add electrons in order to be able to balance this. I'm going to add electrons to the more positive side. And we take the difference of +3 and +2. So +3 minus +2, you get 1. So I need to add a single electron to the left-hand side. Remember, electrons on the left-hand side mean that this thing is being reduced. This thing, the thing that you're starting with, is gaining electrons. The thing that you start with is gaining electrons. So this thing is being reduced. This is a reduction half reaction. Now the zinc, it's a totally different story. It's going from 0 to +2. Let's deal with the law of conservation of mass first. One zinc, boom, done. Law of conservation of mass done. But it's got a total charge of 0, and this has a total charge of +2. Well, the difference between those, +2 minus 0 is just +2. So we need 2 electrons, and you got to add those 2 electrons onto the more positive side. You'll notice the thing we started with is losing electrons. So electrons are leaving it. When you lose electrons, that's oxidation. So this is an oxidation half reaction. Perfect. Yes, I know that they're not gaining and losing the same number of electrons, but that's totally fine. Okay, at this point in time, it's all good. So zinc is losing electrons, and those losing electrons are being transferred to the iron. So the zinc is losing electrons, the electrons are being transferred to the iron, and the iron is being reduced, the zinc is being oxidized, okay? We're going to do one more example, and then I'm going to get you to do a little bit of work. In the next example, we're going to take tin 2+ ions, tin 2+. Ooh. Tin's atomic symbol is Sn. It stands for stannous, whatever, that's fine. So tin 2+, when you take a solution that contains tin 2+ ions and you add chlorine gas to it, I just want to remind you that chlorine gas as a pure element is Cl2. So remember to look at Hofbrinkel or the gun with the trigger and the bullet, okay, to figure out your diatomic and polyatomic elements. So tin 2+, when you add chlorine gas, when you bubble chlorine gas through a solution containing tin 2+, the tin 2+ turns into tin 4+, and the chlorine gas will turn into chloride ions. Chloride ions, chloride is the Cl- ion. So again, let's take a look at the oxidation numbers here. Let's determine, is this a redox reaction? So we're going from +2, the tin is going from +2 to +4. Well, yeah, this is a redox reaction. The chlorine is going from 0 to -1. Again, we have another change. That's a redox reaction. What we're going to do is, I'm not going to ask you whether or not something is being oxidized or reduced yet. Let's write the half reactions and then let's figure out if it's being oxidized or reduced. So I'm going to write the half reaction. Tin turns into tin. I'm basically separating it into two halves. So tin 2 plus turns into tin 4 plus. And then the other half reaction is chlorine gas turns into chloride ions. Cl2 gas turns into chloride ions. Okay, you're going to get sick of me saying this, but every reaction, including half reactions, has to follow the law of conservation of mass and the law of conservation of charge. I really hope those two words are in frame right now. Okay, so we'll take a look at the first half reaction. Tin turns into tin, sure. So does it follow the law of conservation of mass? Well, 1 SN, 1 tin, and 1 SN, 1 tin. Yeah, it follows the law of conservation of mass. Now we have to balance charges. So we've got a total of +2 on the one side, a total of +4 on the other side. 4 plus 4 minus +2. 4 minus 2 is 2. So we have to add 2 electrons to the more positive side. We'll do the same process for the next one, but I really want you to pay attention here. Okay, if you're falling asleep or if you're on your phone, please just pay attention to this one right now. Does this half reaction, so far, we're not done it yet, but does it follow the law of conservation of mass? No, it doesn't. We have Cl2, 2 Cls, and we only have 1 Cl here. So we have to balance the law of conservation of mass first. So what we have to do is we have to add a coefficient of 2 in front of it. When we add a coefficient of 2, that balances the reaction in terms of mass. So Cl2, 2 Cls, 2 Cls over here. We have our mass is balanced. But now we can move on to the law of conservation of charge. On the one side, I've got a total charge of 0. On the other side, I don't. I've got a charge of, what do you think? -2. 2 times -1 is 2 negatives. So this is a total charge of -2. When you take the difference between them, right, 0 minus -2, so 2, but I have to add 2 electrons to the more positive side, always. So the more positive side is on the reactants, so I'm going to add 2 electrons to it. Now remember, half reactions always have to have electrons in them. One of your half reactions has to be oxidation, one of them has to be reduction. Can you tell me which one of these is an oxidation or a reduction reaction? For me, the easiest one to deal with is the one that's gaining electrons. I find gaining electrons way easier to identify. So I see the thing that I'm starting with down here, chlorine, is gaining electrons. So the thing that you're starting with is adding electrons to it. That's gaining electrons, and gaining electrons is reduction. So the bottom half reaction, that's our reduction half reaction. And then on the top, you see that you're producing something, and at the same time, you're giving away electrons. Electrons are leaving, not gaining or entering. So that's losing electrons is oxidation. That's our oxidation half reaction. So what I want you to do is I want you to use these skills, the law of conservation of mass, law of conservation of charge, and I want you to be able to identify oxidation and reduction half reactions. So you're going to get a sheet of paper, and I want you to work on the front side. Take 5 minutes to work on it. Get as much work as you can get done in that time period, and practice these skills. So split up the redox reaction into half reactions, and then try and balance those half reactions. Let Mrs. Cunningham know if you have any questions, or consult your partner or your friend or your whatever, and let us know. Okay, have fun.